So today we're working on 2.4b, factoring and solving quadratic equations. So just to kind of review for solving, we're going to do basically factoring and eventually we'll get another quadratic formula. But when we are trying to solve, most of the times when we have a quadratic, right, ax squared plus bx plus c, we're going to probably try to solve that by factoring. That's what we're going to try to do the most this entire school year. Is anytime you see a quadratic, right, we're usually going to try to set it equal to 0 and solve by factoring. We're going to do that a lot. So again, it really depends on how many terms on what type of factoring we're going to try. We covered this in 2.4a. So we have two terms, three terms. First, GCF. Two terms, right, is going to be a difference of squares. Three terms is some type of trinomial. So when we're solving, we're going to set our equation equal to 0. Why do we do that? Well, it allows us to use the zero product property rule. So what that says is that if you're multiplying two expressions, right, and they're equal to 0, right, if that product is equal to 0, the only way for that to be possible is either A equals 0 or B equals 0. The only way to multiply two expressions together and get 0, one of them has to be 0. Do I know which one? No, I do not. One of them are 0 or maybe both of them, but we're just going to say that probably one of them is 0. So we're going to use the zero product property a lot to solve. So looking at example 1, it's a quadratic because it's x squared. So in order for us to solve, right, I'm going to try to factor. It's already set equal to 0. So I do notice there's a GCF, right? So GCF of 2x. So if I factor out a 2x, I'd have a 3x minus 11. So if I quickly mentally distribute that back through, do I get what I started with? 2x and 3x, that's 6x squared. 2x minus 11, if you multiply those, you get minus 22. So I'm good. So the only way for this to be multiplied by that and equal to 0 is either 2x equals 0 or 3x minus 11 equals 0. It's the only way for that to happen. So if you divide by 2, x equals 0. Add 11, divide by 3, x equals 11/3. Those would be your two solutions. And again, you're solving quadratics. So quite often you will get two solutions. Okay, example 2. Already set equal to 0. Right? GCF, 3 terms, it's okay. GCF is 1. So I'm going to try to factor it. So good thing, right? 3 is prime. So it's 1x and 3x. If it is going to factor, if it doesn't factor, we have a special little tool we can use, but we'll talk about that later. Right? Factors of 6, 1 and 6, 2 and 3. Again, how do I know it can't be 3 and 2? Well, because this 3 here would mean there's a GCF of 3, and we said there wasn't. We said it was 1. So that combination cannot work. Right? Same thing. It can't be 6 and 1. That wouldn't work either, because you'd have a GCF of 3. So that literally eliminates half of my choices. So it's helpful to know that GCF is 1. So let's see. 2 and 3. 2x, 9x. Can I make 2x and 9x equal to positive 7? Yeah, if this was positive and this was minus. So if this was plus and this is minus, it would be factored. So I have 3x minus 2 times x plus 3. That equals 0. So either 3x minus 2 equals 0 or x plus 3 equals 0. Right? So subtract 3. Add 2, divide by 3. So you get 2/3 or negative 3. Those are your two solutions. So it's a quadratic, set it equal to 0, try to factor it. Once I get there, I set each factor equal to 0. So when you're multiplying two factors together and they equal 0, one of them's got to be 0. I don't know which one. So we're just going to assume one of them is 0, make both 0, and solve. So now if you look at example 3, it's different than 1 and 2 because it's not equal to 0. And that's going to happen sometimes. So I'm going to move the 28 over by subtracting it from both sides. Now you might wonder, well, why didn't you move the other 2 over? Well, when you're factoring, I'll tell you right now, your life will be so much easier if you have a positive x squared. It makes factoring 10 times easier. So I would encourage you to make it x squared positive as much as you can. So here, GCF would be 1. So if it's going to factor, it's got to be 2 binomials because it's not a difference of squares. Good thing is 1, the only way to get 1x squared is 1x and 1x. So now I need the factors of 28 that give me 3. So 1 and 28, 2 and 14, 4 and 7, that'll give me 3. So plus 7 minus 4. So set x minus 4 equal to 0, x plus 7 equal to 0, add 4 to both sides, subtract 7 from both sides, and there we go. There are my two solutions. Again, I use 4 and 7 because when they multiply to give me 28, I can add to make them give me 3x. So you need multiples of 28 that you can add together to get positive 3. So that would be 4 and 7. Okay, so now if you look at 4, similar to 3, it's not equal to 0. So I'm going to set it equal to 0. I'm going to subtract 49. Now it's equal to 0. Now, you might think there's a GCF of 9, but it's not. You might think there's a GCF of 3, but there's not. Right? The GCF is 1, but it is a difference of perfect squares. So this is going to factor into two binomials, plus or minus. So what number do you square to get 9? 3. What do you square to get x squared? X. What do you square to get 49? 7. So 3x plus 7 equals 0, or 3x minus 7 equals 0. And now it's just a two-step linear equation. Subtract 7, divide by 3. Add 7, divide by 3. So x equals plus or minus 7/3. Now, there is another way to solve that. The fact that it's 9x squared equals 49. Maybe you can think about if you can find another way to solve it other than factoring the way we did. You can actually use square roots. So think about that. You get the same answer, but it's another way to approach it by dividing by 9 and then taking the square root. See if you can figure that out. See if you can solve it a different way, and you should get the same answer. Okay, looking at 5. 5 is really different now, right? Doesn't equal 0. The x squared is on one side, the other values on the other. So I'm going to move both of these to the other side. So I'm going to subtract 11x, and I'm going to add 2. So again, I took 11x and 2 and moved them to the right. Some of you are like, well, why don't you just move the 5x squared over? Because I don't want a negative 5x squared when I go to factor. It just makes the factoring more complicated. So it's set equal to 0. Right? GCF of 1. So if it does factor, it's going to be two binomials. And if it doesn't factor, again, we're going to start talking about that later on the back side. kind of get into that little. Again, 5, good news, is prime. And then 2, right? The only factors of 2 are 1 and 2. So let's see, 10x, 1x. I can make 11 with that. Minus and minus, so if they're both minus, that would work. So 5x minus 1 equals 0. X minus 2 equals 0. So x equals 2 is one solution. Add 1, divide. 1/5 is the other solution. So you get 1/5 and you get 2. Again, understanding you're solving a quadratic. The x squared means there's going to be usually 2 different terms. 2 different answers. Okay, now 6 looks really different. It doesn't look like any of the other problems we've done. So why don't we try to make it look somewhat similar to at least some of them. So what about we try distributing this? So 2x squared minus 1x equals 6. Okay, that kind of looks like number 3. So now I'm going to subtract the 6 over, because I want to set it equal to 0. Right? Almost any time I see x squared, I'm thinking, put everything on one side, set it equal to 0, try to factor it. So again, good news is 2x is only 2x and x. So now I need the factors of 6. 1 and 6, 2 and 3. So let's see, 3 and 2. Will that work? 3x, 4x. Can I make 1 with that? Yes, I can. This is minus, that's plus. So 2x plus 3 equals 0. X minus 2 equals 0. And now you just solve, right? The 1 on the right is not too bad. Add 2 to both sides, so you get 2. 1 on the left, we're going to subtract 3. And then divide. So you get negative 3/2. So all 6 of those problems, we set everything on one side, either left or right, doesn't matter. Set equal to 0, then we tried to factor it, then we set each factor equal to 0, and that's how you solve it. And we're going to use that method a lot in this class, because you're going to see quadratics throughout the school year. Okay, go ahead and flip it over. Alright, so for problem 7 and 8, we're going to solve using square roots. You could try to factor this, but it's a lot of extra work that we don't want to really do. So just a reminder, when you're solving an equation like x squared equals 25, there are actually 2 solutions. The obvious one for most of you is positive 5. But please remember that if you take negative 5 and you square it, that's also a solution. So when you're solving an equation, there's actually 2, we want all the answers. So there's actually 2 solutions. So you got to be careful. So when you're solving an equation and you're taking a square root, there's going to be a plus and a minus. Because you're technically solving this equation, x squared equals whatever number. So if you look at 7 and 8, right, compare them. Look up to my screen at number 5 and 6. These 2 look totally different than 7 and 8. So I'm going to solve 7 and 8 really differently, or in a different manner, than I did 5 or 6. So using square roots, that means, right, this symbol here. So in order to do that, I got to get this guy by itself. So I'm going to add 4 to both sides. Then I'm going to divide by 3. Okay. So now, if I could somehow get rid of that square, life would be good, because I just had to subtract 3 after that. Well, in order to get rid of the square, we're going to use the inverse operation, which is going to be the square root. So what I do to one side, I have to do to the other to preserve equality, right? In equations like a balance scale, If you take weight off or do some operation on the left, you got to do it on the right as well to preserve the balance. So on the left side, life is good. It's just x plus 3. On the right, this becomes plus or minus 5. Because you're solving an equation, there's a positive and a negative root, not just the principal root of 5. Now I'm going to subtract 3. Okay. Now, this is pretty good, but we can go one step further than this. Actually, 2 steps probably. Negative 3 plus 5, negative 3 minus 5. So 2 and negative 8. So those would be your 2 solutions. So some of you might be wondering, well, why didn't we solve it like the last 6 problems? Well, in order to do that, you would have to take x plus 3, multiply it out, times it by 3, and then subtract 4. Get everything on one side, move the 71 over, and then factor, right? It's a lot of extra work that you can do if you want, but we don't need to do that. We can solve with the square roots. So looking at example 8, right? So I want to isolate this. So I'm going to subtract 7. And then I'm going to divide by 2. Okay. So now if I could just get rid of that square root, well, I can square root both sides. Okay, now this is going to be plus or minus, but the square root of 20, it's not a nice whole number, but we can simplify it. Right? It becomes 2 root 5. Think back to when you did this last year in Math 2. Right? You're looking for a perfect pair. Pairs. So for every pair, you can take 1 out. So I took out 1, 2. And what's left is the 5. Add 6. Now, this is not going to be a nice whole number, so I am fine with us stopping there. If you went any further, there's no need to, because it's not going to be any more precise. It's just going to end up giving you a decimal. So that is an acceptable answer. Example 7, I went further because I could get all the way to 2 constants as answers. Nice, 2 whole numbers. Okay, so these first 8 examples, all 8 of them we can solve. Sometimes there's going to be some quadratics that you can't solve with square roots. You can't solve by factoring. But that's still not going to stop us. So we're going to get into what we call the quadratic formula. Not today, but we're going to get into it in our next lesson. So 9 and 10 are practicing using the quadratic formula, because sometimes you're going to have to plug numbers in and you're not going to get a pretty answer like number 9. And I want you to be able to simplify as far as you can. And number 10 is basically plugging numbers into the quadratic formula. Real simple operations, but it can be confusing for a lot of students because there's a lot going on. So 9 and 10 are getting us ready for the next lesson. So we're going to simplify this, right? So one thing with fractions is you're able to split this up. So you can write this as 4 over 6 plus 18 root 3 over 6. And you can simplify, right? 4 over 6 is just 2/3, right? 2 goes into here 3 times, twice. 6 goes into there once, into there 3 times. So this would be 3 root 3. So this would be 2/3 plus 3 root 3. That would be your simplified answer. Okay, 10 is a couple steps before 9, so we're going to simplify it. So negative 6 plus or minus, right? We're going to go 6 squared is 36. So 36. Now this is where most students mess up, is right here. This is the part. Negative 4, 2, negative 3. So it's a positive number because there's 2 negatives. The good thing about multiplication, it doesn't matter the order once you multiply. So you could do 4 times 2 times 3. You could do 2 times 3 times 4. You could do 3 times 2 times 4. I don't care. Just multiply the 3 numbers together. So 4 times 2 is 8, times 3 is 24. All over 4. So -6 plus or minus square root. Okay, 36 and 24. Right, 36, 46, 56, so 60. So starting to look kind of like number 9. Well, root 60 can be simplified. Okay, so we have 6 and 10. We have 3 and 2. 2 and 5. So I can take out a 2. What's left is the 5 and the 3 all over 4. So now it looks almost identical to number 9. So again, if you split up the fraction, -6 over 4 plus or minus 2 root 15 over 4. Right? Simplify. 2 goes in here 2, into here 3. So -3 halves. 2 goes into there once, into there twice. Plus or minus root 15 over 2. Now, since these are the same denominator, you could technically write this like this. Either one of those would be acceptable. So this is what's going to happen when we can't solve our quadratic by factoring our square roots. So hopefully you kind of see why it's nice to solve it by factoring. Because there's a lot of extra little work in here, a lot of chances to make a mistake. So again, solving quadratics. Again, just like we have up here in blue, that's a quadratic, the thing I'm boxing right now. If we see that, we want to try to set it equal to 0, try to factor. That's usually our best way to solve. If not, if we have something that looks like number 7 and 8, we solve with square roots. And if that doesn't work, we'll eventually get to the quadratic formula. Make sure